Hello, it's Brian with Arduino Academy, and I hope everybody is doing great. This time, we're going to take a break from basic programming and talk about planning, design, and pseudocode. Now, this may sound a little weird and a little lame, but trust me, you don't want to skip this lesson, especially if you're new to Arduino. Specifically, we're going to break this lesson down into two main parts. First, we're going to talk about planning your circuit build and operation, and then we're going to talk about planning your code. Here's a process that may sound familiar to a lot of folks, especially newbies. You have an idea for a project, so you immediately fire up the Arduino IDE and grab your breadboard and soldering iron. Perhaps you jot down some ideas about what you want the project to do, or maybe even go as far as to sketch a crude drawing, but then it's time to dive right in and start. This may work for simple projects and experiments like blinking an LED or turning an LED on and off with a push-button switch. But when dealing with more complex projects, there is a better way. To demonstrate, I'm going to start with a little personal background. When I was earning my electrical engineering degree, the last 2 semesters had required classes that were centered around designing and building some sort of relatively complex widget. We'll call them Design 1 and Design 2. And again, each design class lasted a whole semester. And since the classes were during the last 2 semesters before graduation, we were supposed to use the knowledge we had gained from all previous semesters and classes to finally roll up our sleeves and create something beautiful. Okay, well maybe beautiful is a wrong adjective, but you get the idea. Design 1 was all about developing an idea for a project. Once the idea was there, we formed groups of 3 or 4 people. After that, we needed to come up with block diagrams, schematics, and try to source parts on a very slim budget. The following semester in Design 2, we got to fire up the soldering iron, dust off the hand tools, open the IDE, and start to build prototypes of our creations, write code, and test, eventually, and hopefully, coming up with a working finished project we could show off to the university, other students, and our relatives and friends who would be attending the demonstration assembly we'd have right before graduating. And here's the point. We didn't just think of an idea and immediately start to write code and wire up parts hoping we'd nail it. We went through a process, a design process, and this is what you should do. Now, don't freak on me. Your design process probably won't last months, weeks, or even days unless you're tackling a really, really tough problem. But a little forethought design will go a long way to a successful project. Let's start with a little overall project planning. So you have this idea. Let's say you own a machine that automatically feeds your cat and dispenses food at the appropriate times. You may want to fire up the IDE and your soldering iron, but one of the first things you should do is go old school and grab a pen and paper, or just type a doc if you don't like going old school, and write down the things you want the project to do. For our cat feeder, we may want it to automatically dispense food at certain times, because, wouldn't be much of an automatic cat feeder unless it did at least this. We may want it to alert us when the machine needs to be refilled with more cat food, be able to detect if there's enough food still remaining in the dish before dispensing more, be able to somehow dispose of old food in the bowl if it isn't fresh, or at least alert us so we can do so, and maybe connect to our Wi-Fi network so we can do things like get alerts on our phone if the machine needs to be refilled with food, monitor the cat's eating habits, and stuff like that. Now, all this sounds amazing, and it's very tempting to jump in and try to create something that does all the above and maybe even more. But the principle of incremental design tells us this is a bad idea. Instead, we should first ask ourselves something like, what is the minimum functionality my widget needs to have? So going back to our cat feeder example, we definitely need it to automatically dispense food at certain times. We need it to alert us when the machine needs to be refilled. And we probably don't want it dispensing food if the dish is already full. Do we really need it to dump the old food after a certain amount of time? Well, not really. We can do that ourselves. And it doesn't really need to be connected to the internet to work, so we'll cross that one off. Now, I'm not saying that we shouldn't eventually, and the key word here is eventually, add the last 2 items once we get the first necessary features working. Because it would be nice to maybe have it connected to the internet and somehow dump old stale food on its own. But we'll worry about those things once we get the basics down. We can always add them later once we get the minimum functionality working correctly. So now I kind of hope you get the idea behind the principle of incremental design. Now, we need a circuit. To help us break down a complex circuit into smaller, easier parts, our friend the block diagram will come to our rescue. A block diagram is just an abstraction where parts of a complex circuit or system are represented by blocks. To draw a block diagram, we can go old school again and, sketch it on the back of a napkin or something. Or we can use some sort of software tool like Visio, PowerPoint, or even more complex CAD software if you have access to that. It's just really your choice. To demonstrate, let's first take a peek at what a block diagram for our cat feeder may look like. Now, I'm no artist, but I drew this by hand anyway, so promise not to laugh too hard at my drawing skills here. So first, we want our cat feeder to plug into a standard outlet, so we don't have to worry about batteries dying if we go on vacation or something like that. I drew these dashed lines around all the other blocks because our power supply is going to power the Arduino, motor, sensors, and whatever else needs power. And instead of building our own custom power supply, maybe we can just use a wall wart or some off-the-shelf pre-rolled unit. But right now, we're just going to represent it as a block. Next, we have a block to represent the Arduino board, which is kind of like the brains of the whole thing. We'll probably use it to keep track of time, so we feed our kitty at the right times in addition to controlling and communicating with the other parts. Notice the arrows, too. The two-headed ones hint that we may need two-way communication between one block and another, and the single-headed one suggests that one-way communication may be okay. Now, we have a sensor and a circuit to detect if the dish is empty. This could be some sort of scale or sensor that measures weight, or maybe something else. But right now, it's just a block. Finally, we have the three other blocks. And by now, you should kind of get the idea of how to draw a basic block diagram for your project. It doesn't have to be pretty or something you'd submit to the patent office. It just needs to be something that you understand, which breaks down a complex project into smaller, more manageable parts. And I will have this available for download, by the way, so you guys can use it as an example. Now, the next step would be to take the individual blocks and fill them with real components. Now, some of you may know how to draw schematics and others not so much. And this is a topic that's a bit outside the scope of this course, but many prefab solutions and shields are available these days. For example, we can probably use a wall wart, as I stated before, for our power supply instead of designing our own. There may be motor control shields available for Arduino that can handle that part. And like we said before, maybe we can use an electronic scale or hack one to see if the dish needs to be refilled. And if you're comfortable designing your own circuits for these purposes, then you should definitely consider it. You'll save money, hone your electronic design skills, and have more control over how your cat feeder or whatever you're making works. Regardless, even if you're not quite there yet, you can still make some really cool things with Arduino and prefab solutions, so don't get discouraged. Now, let's say we have most of our circuit design planned. It's time to start thinking about our code. There's a great tool called pseudo that's perfect for this.